When I say work, what is the first thing that comes to your mind? Hello, my name is Muhammad Haris. Today, I would like to explain to you about work, power, and energy. We will spend most of our time talking about force and the way they make things move. You need to understand force before you can understand work, because work is what happens when you apply a force over a certain distance to a system. A system just being whatever section of the universe you happen to be talking about at that time. For example, if you are using a rope to drag a box across the floor, we might say that the box is your system, and the force you are using to put on it is an external force. Let's say you're pulling on this box system by dragging it straight behind you, so the rope is parallel to the ground. If you are using the rope to pull a box for 1 meter, we say that you are doing work on the box, and the amount of work you are doing is equal to the force you are using to pull the box time the distance you move in. For example, if you pull the rope and therefore the box with a force of 50 newton while you move it 5 meters, then we say that you did 250 newtons meters of work on the box. However, work is expressed in units known as joules. Now, sometimes the force you are applying to the object won't be in the exact same direction as object is moving. Like if you try to drag the box with your hand higher than the box, so that the rope was at an angle to the floor. In that case, the box would move parallel to the floor, but the force would be an angle to it. And in such an instance, you have to use one of the tricks we learned earlier when we first talked about vectors. You need to separate the force you are using on the rope into its component parts, one that parallel to the floor and one that perpendicular to it, to find the part of the force that is parallel to the floor. That is the one that's actually pulling the box forward. You just need to apply the magnitude of the force by the cosine of the rope's angle to the ground. You remember that we typically designate an angle in a system as theta. So, to calculate the work he did on the box, you just multiply the horizontal component, or F, times the cosine of theta by the distance you move the box. That's one way physicists often write the equation of work, those that are equal to force times distance times the cosine of theta. Next, we go to energy. What we know about energy? Energy and work use the same unit as energy. In fact, that one of the ways to define energy is the ability to do work. There is all different kind of energy, but today we'll be talking about two of them: kinetic energy and potential energy. Okay, we go to the kinetic energy. It's the energy of motion. When the box is resting on the ground, we say that it had no kinetic energy. But once you apply the force and it start moving, it did have kinetic energy, and the energy of the box changed, which means that you did work on it. More specifically, the kinetic energy of an object is equal to half of its mass times its velocity squared. Okay, so if the box has a mass of 20 kg and at some point while you are dragging it, it reached a velocity of 4 meters per second, we say that its kinetic energy at the moment was 160 joules. Then there is potential energy. In other words, potentially energy is energy that could be used to do work. Calculating the gravitational potential energy is easy enough. It's just the force of gravity on the object. So the object mass times gravity and multiplied by the object height, which means that just by knowing that this book mass is about kilogram and that we held it about a meter above the ground, we can calculate as potential energy, which is 9.8 joules. Another type of potential energy that shows up is spring potential energy. Rather, it's the type of potential energy that is specific to spring and the force of the spring equal to the distance by which it is either compressed or stretched times a constant. We write it K. This equation is known as Hooke's law. Combining work law, the idea that work equals force times distance, we can find the potential energy from a spring. It's a half times K times the distance square. For example, if you have a spring with a spring constant of 200 Newton meters and block is compressing it by half a meter, then potential energy of the block will be 25 joules. So, some systems can lose energy, and these are known as non-conservative system. It is just related to one of the most fundamental principles of science. The energy can neither be created nor destroyed. But system can lose energy when frictions from the box dragging on the floor generates heat to non-conservative system. You can still talk about their kinetic energy, potential energy at any given moment. But conservative system is not that doesn't lose energy through work. For example, a simple pendulum. When the pendulum is at the top of its swing, stop moving for a brief moment as it changes direction, meaning that its kinetic energy at the point is zero. But it has a lot of potential energy because the gravitational force can do work on the pendulum, pulling it down until it reaches the bottom of its swing. At the bottom of the swing, that potential energy becomes zero because gravity can't pull the pendulum down anymore. But now, the pendulum has lots of kinetic energy because it's moving through the swing, and it turned out that at any given point in the pendulum motion is kinetic energy and potential energy will add up at the same number. If its potential energy increase, its kinetic energy will decrease by the exact same amount. So now that we know how to define word, we can use that definition to help explain another common term that physicists have a very specific meaning for power, or more specifically average power. Average power is defined as work over time and is measured in watts. So remember that box you were pulling? We figure out that you did 250 joules of work on the box when you moved it 5 meters. If you took 2 seconds to move the box, then your average power output was 125 watts. Now, we can also describe power in another way by putting two different facts together. One, that work is equal to force times distance, and two, the average velocity is equal to distance over time. Knowing this, we can say that power is the net force applied to something with a particular average velocity. If you move the box 5 meters in 2 seconds and its average velocity was 2.5 meters per second, so the force you were using to push the box times the box average velocity would also give you an average power output of 155 watts. Alright guys, that's all from me. Thank you for watching and thanks for your times. Alright, bye.